Hi, this is Mr. Mac. Now, in the last concept video, I developed the quadratic formula. In other words, if ax squared plus bx plus c equals 0, then x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. With that being known as the quadratic formula. Now, what can we learn from the quadratic formula? When I was quite young, in Algebra 1 class, and the quadratic formula was presented to me, the plus or minus sign gave me a little bit of a problem for a while. I thought they'd made up a new operation and I'd been sick that day or something, and or I hadn't been listening and I didn't know what it was. So plus or minus just means you get one answer when you add, and you get another answer when you subtract. So now, if you look at the quadratic formula, we're expecting ordinarily two answers to a quadratic equation. And the quadratic formula gives us those two answers by adding the square root of b squared minus 4ac to something and then dividing by 2a. And then it gives us the other answer by subtracting that same value, the square root of b squared minus 4ac, from something and then dividing by 2a. So as mathematicians looked at this formula, they determined that the square root of b squared minus 4ac was pivotal in understanding the roots of the quadratic equation. Further, it's b squared minus 4ac that's actually under the radical. So what they did is they decided to define b squared minus 4ac as a particular quantity, and they gave it a name. They call it the discriminant. Now, I'm going to digress here for just a minute. When I was quite young, my parents, probably through an act of childish cruelty, gave me a book titled 1001 Curious Jokes, Riddles, and Puzzles. And in there was a section about ant jokes, things like what ant lives in a house, and the answer was occupant or resident, and what ant sits in a seat, that would be occupant. And now I've added to that, what ant lives in the quadratic formula, and the answer is the discriminant. Discriminant. I know that's pretty terrible, but you have to listen. Okay, now, let's go back to this. b squared minus 4ac is the discriminant. Now, guys, be careful. It is not the square root of b squared minus 4ac that is the discriminant. It's just b squared minus 4ac that's the discriminant. Now, the first thing you should notice is that b squared minus 4ac in the quadratic formula is being square rooted. And then we're adding it to get one answer, and we're subtracting it to get another answer. So the first thing that may pop into your head is, what if b squared minus 4ac is negative? Well, now, if b squared minus 4ac is negative, now notice I'm writing that less than 0. If b squared minus 4ac is negative, mathematically we say if it's less than 0, that means we're taking the square root of a negative number. And what kind of an answer do we get when we take the square root of a negative number? Well, we're going to get an imaginary number, and then when we add that to a real number, because negative b will be a real number, and divide by 2a, we're going to get a complex number. And this complex number will be non-real, because all real numbers are also complex. But in this case, we're going to have a complex non-real number. And since this is not zero, here we go. Since this is not 0, we're going to have two different numbers. So when b squared minus 4ac is less than 0, we're going to get two complex non-real solutions. The next thing that might pop into your head is, what if b squared minus 4ac is equal to 0? Well, what happens then is that you're going to take the square root of 0, which gives you 0, and you're going to add 0 to negative b and then divide by 2a. And you're going to subtract 0 from negative b and then divide by 2a. And what will happen is you will get the same answer both ways. So ordinarily what we say is when b squared minus 4ac is 0, we get one real rational 0. Because you can take the square root of 0 and just get 0. You don't have a square root left. Now, what happens if b squared minus 4ac is greater than 0? In other words, is positive? Well, there are two things that could happen. If it's a perfect square, then we will get two real rational zeros, because if it's a perfect square, that's what you're taking the square root of. You can take the square root of it and you'll get a rational number. Now, if it's not a perfect square, but it's positive, then you will get two, because they're different. Even though you're taking the square root and getting a rational number, you'll be adding once, subtracting once. You'll get two real irrational zeros. Now, there are, in just about every Algebra 2 book I know, there are charts that give you this. And a lot of students just memorize the charts. And if you want to do that, that's okay. But I really think that better than that is looking at this and understanding what you're going to get when these different things happen. But it all pivots around the value of the discriminant. So in many of the exercises, they're going to ask us for the value of the discriminant. And we'll start off by determining the discriminant, and then we'll interpret what that discriminant means and see what it is of these that we're going to get. All right, now, one other thing about this. Remember, every quadratic equation has a related quadratic function. This quadratic equation has the related quadratic function y equals ax squared plus bx plus c. Now, remember, the x-intercepts of the quadratic function are the solutions to the quadratic equation. So if we get two complex zeros, sorry about that, my wife called and I paused the video. Let's see if I can remember where we were. See, each quadratic equation has a related quadratic function, and that's the function we get when we put y in rather than 0. And the x-intercepts of the quadratic function, the places where the parabola crosses the x-axis, are the solutions to the quadratic equation. Now, if you look down at the solutions to the quadratic equation, they should be the places where the parabola crosses the x-axis. So if you have a discriminant that's less than 0, you get two complex non-real zeros. That means that the parabola is not going to cross the x-axis. So you're going to have a parabola that's either all above the x-axis and opening upward, or all below and opening downward. Now, if you have one real rational zero, your parabola is actually going to just touch, or in other words, the vertex of the parabola is going to be on the x-axis. And if you have two real zeros, either one of these, your parabola is going to actually cross the x-axis twice. So by looking at the discriminant, you can you can find not only what kind of roots the quadratic equation has, but you can also see how many times the parabola is going to cross the x-axis. That's a pretty powerful thing for the discriminant to tell you. Now, we've gotten to the point now where we've spent a good deal of time studying the quadratic formula, the quadratic function, and quadratic equations. So I'd like to just summarize the methods we have of solving quadratic equations. The first method that we learned was graphing. That was using the graphing calculator and the trace, not the trace features, but the calculate menu to find the zeros. Now, graphing will only approximate. In other words, it will not give you the actual square root number, 1 plus square root 2 over 7 or something like that. But it will give you an approximation to maybe 8 or 10 decimal places, and that's pretty good. So you do need to know how to solve quadratic equations by graphing. Now, we also know or learned how to solve quadratic equations by factoring. Now, it turns out, oh, by the way, graphing doesn't work if there are non-real solutions, because then the parabola is not going to cross the x-axis. Now, factoring is a method that will give you actual values, but it only works when the roots are rational. Then we had the square root principle, and that was kind of a little niche method when you had the binomial squared and x was just inside that binomial, and that was, or PLE, I think. Square root principle was kind of a little niche method, but we used the square root principle to complete the square, and then completing the square and the quadratic formula are the two very powerful methods of solving quadratic equations, and that will give you solutions to all equations. So, as you are preparing for assignment quizzes and tests and so forth like that, make sure that you know how to solve quadratic equations by all of these methods. Don't just focus in on one, because if you do, there will be questions asked that you probably won't be able to answer. Okay, that takes care of the second half of the video.